This video looks into the concept of wave scattering. The phenomenon of wave scattering corresponds to the collision and scattering of a wave with some material object. For instance, sunlight scattered by raindrops to form a rainbow or water ripples bending around a stone. This bending of a wave primarily depends on the relative size of the obstacle to wavelength. Let's play with this ratio and identify different regimes of wave bending using a very popular numerical technique in electromagnetics, namely the finite difference time domain method. The size of our domain is 16 wavelengths by 16 wavelengths. The resolution of the simulation is 20, which means our domain is equivalent to a grid of 20 equal units in each dimension. The frequency of our wave is 1 and a metallic obstacle is used for scattering. The entire computational domain is encased by an absorbing boundary condition. This is implemented using perfectly matched layers, which for the purpose of this experiment is made to be 1 wavelength thick. Now let's look at the simulations. As can be seen, the wave propagation is essentially unaffected when the obstacle size is very small compared to the wavelength. When the obstacle size is comparable with the wavelength, we can see little diffraction and a region behind the obstacle where there is no wave. And finally, when the obstacle size is much larger as compared to the wavelength, we see no diffraction. But an interference between the incident and the reflected wave can be observed clearly. A shadowed region can be seen behind the obstacle. This is the MEP code used to run these simulations. So we looked at the 3 different regimes of wave bending. We thank Professor Uday for giving us yet another opportunity to learn things creatively. Thank you for watching this video, and please do not forget to subscribe.